All right, today's topic is entity relationship model. This model is not necessarily a database model, but it is basically a graphical model which is used to represent or which is used in designing a database system from the real world. Because we in database system, when we design a database system, we are representing a part or a small section of the real world, which in database terminology we call it the mini world. So the part of the world or the mini world that we are representing can be converted into a graphical system, and to convert that into a graphical system which ultimately can be converted into a database system. That is where entity relationship model is used. So when we talk about entity relationship model, this model tries to describe data or try to see the real world as entities, as attributes of the entities and relationships. So in entity relationships, we will be dealing mostly with what is entity or what is attribute, what is relationship, how does these things represent the real world. So that is what entity relationship model is about. So the first thing is, what is entity? So when we say what is entity, uh, we are uh, trying to see how how this model tries to represent the real world. So an entity, the base is the basic object in entity relationship, is the basic object of the model which represents an entity of the real world. So that entity can be a thing, sorry, it can be a thing which with an independent existence. Okay, so or it can be some kind of objects, which can be abstract objects which has conceptual existence. For example, a job is a conceptual, has a conceptual existence. A university, it could be a university, or it could be a student. Okay, so a student is an entity, a university is an entity, a job is an entity. So this is how entity relationship models tries to look at, tries to represent the real world as entities. Now these entities have attributes. So these entities are defined by its attributes. So an attribute, an entity will have have attributes. So that is the properties that describes the entity. For example, an employee, a student may be described by his or her name, her age, her phone number, the course that he or she offers. So that those are attributes that defines an entity student. Now, if I am to represent student as an entity, so this is student. So this student has a name. This student has, let us say, roll number. This student has uh, this student has age. How old is the student? The student has phone number. So, and on it goes. So we are trying to see that student is an entity which is defined by the attributes, okay, with the following attributes. Sorry. So those attributes are name, roll number, age, and phone number. So we can have more attributes. This is just one example. Similarly, as we can also represent uh, a department. That means department of a university. So a department will have name of the department, head of department, campus, for example, or location. That is the campus where the department is located. Okay. So likewise, we have two entities. One is student, another is department. Department is defined by its attribute, name of department, head of department, the campus where this department is located. Similarly, student is also defined by this attributes. Now, the attribute values, the particular entity will have a value for each of its attributes. That means students will have name. In this case, we are trying to represent the entity students. Now, if students, suppose we say students, then all students will have names, will have roll numbers, will have age, will have phone numbers. Similarly, all departments will have names, will have head of department, will have campuses. So the value will be the actual value of the data will come in here. Under this attribute, we'll have multiple names. For example, ABC is a name of a student, and similarly CD is the name of a student, and EFG is name of the student. So these are the values, the attribute values. Now, what happens is that when you are actually designing the database system, the actual data is, actual data is the value of the values, the collective value of the attributes. So that becomes the actual data. So that is why the attribute values that describes its entity become the major part of the data which we store in the database system. Now, now we have one more thing, relationship, for example. In this case, we are not specifying any kind of relationship between department and students. Suppose if we have to specify name of the relationship between these two, we will put one more attribute, the department in which the student is enrolling him or himself or herself. So this is name of the department. Now, what happened is that here, automatically this name of the department, this and this will have some kind of linkages, some kind of relationship based upon the value of this attribute of the department. We call it name. So name of the department and name of the department, these two will be similar. So this is how there is a relationship between students and the departments to which they are enrolling themselves. So that is relationships. So there will be multiple relationships. Here we have only 1:1 relationship. Relationship can be 1:1. It can be 1:many, or it can be many:many. Okay, so we can have different types of relationship among these entities. So basically, as we said from the beginning, that entity relationship comprises of three things. That is entities which are defined by its attributes, and those entities are further related or further linked together with the help of relationship, depending upon what relationship it has in the real world. Now, attributes are, as we said, the most important, basically, ultimately, the most important components of entity relationships. Because, as we said here, what we are, at the end, what we store in a database system is the value of those attributes. So therefore, there are ER model defines that there are different, according to ER model, there are different types of attributes. So that we shall see one by one. So the first two types is composite and simple attributes. These are like opposites. That is why we are putting it together. Composite and simple attributes. In some books, you will see composite versus simple attributes. Now, composite and attributes can be divided into smaller subcomponents. For example, if we say address is an attribute, okay? So this address can be further divided into, for example, locality, then we can have the city or village, then we have the state, then we have the postal index numbers. So this address itself is an attribute which can further be divided into locality, city or village, state, and PIN number. Now, this, for example, if we put address, we put phone number also. Okay, suppose we are putting phone number also, then we can further divide these phone numbers into, if it is a landline, then you have to the code, okay, the STD code, and then the landline number, or if a country code, and so on. Okay, so it can be further subdivided into different components again. So this is one composite attributes. Similarly, location also can be divided into house number, for example, or if it is a proper city, then street, or it can be apartment number also, if it is a apartment building. Okay, so and so on. So this attribute called address becomes an attribute, a composite attribute, which has so many sub parts or sub components. On the other hand, simple attributes are also called atomic attributes. That the name itself suggests that simply these attributes are no longer divisible like a composite attribute. So, for example, age of a person's age would be a simple attribute, because person will have one age value only. For example, age is 24. So one person cannot be 24 and 25 and 30. They cannot have multiple age value. Either one of them, only one of them will be taken. So that's why this is also called, simple attribute is also called atomic attributes, which are not divisible anymore. Then the next is single attributes. Okay. You may ask a question that why don't we make everything atomic? Why can't we make? Why do we have to make a composite attributes? For example, these are useful when you are modeling a situation in which the users will sometimes refer to the composite value, Okay, for example, address as in totality sometime, or sometimes they want to find out only the village or the state or the postal index number. Okay, so in that kind of situation, composite attribute is necessary. So, but if the composite attribute is reference or is used only as a undivided, as a whole, then there is no need to have a subdivision or subparts of the composite attribute. Only when it is referred partially at the same time as a whole, then you need a composite attribute. Then we have single and multi-valued attributes. Now, single attributes are attributes that have a single value for an entity. As I said, and if I take the example of age again, so for a single entity or single person, age will be only one age, 24. If they is 24, they cannot be 30, they cannot be 40 at the same time. So this is only one value, that is single value. Now, an attribute can have a set of values also. It cannot, I mean, in some cases, it can have a set of values. For example, educational qualification. Okay, if we talk about educational qualifications, then you will have multiple values. For example, you have passed matriculation, you have passed your 12th, then you have passed your graduation, or you can have graduation degree. Also, you may have multiple graduation. For example, BA English, and then you go back and did, for example, the BA, say psychology. Okay. Similarly, you can have a postgraduate degree and so on. So an educational, if the attribute is educational value, then the educational qualification, then the value is not just one only, but in this case you have 1, 2, 3, 4 different values. So that is called multi-valued. Okay, so multi-valued attribute can have in some cases lower and upper bound. The number of values allow for each individual entity. Okay, say for example, how many cars, number of cars owned by a person. So if there is, suppose, let us assume that the city has a rule, or the state has a rule, that a person, in one person's name, only 3 cars can be registered. Okay, that means the upper bound value is 3, then the person can have no cars also, 0. So the lower bound is 0, the upper bound is 3. So similarly, like that, multi-valued attributes can have a lower bound and upper bound. I'm just assuming it. There's no such rules. Okay. Then the attributes can also be stored and derived. In some cases, 2 or more attribute values are related. For example, okay. Now, a good example for this would be date of birth. If date of birth is an attribute, then you have to specify what is the date of birth. Okay, so based on the date of birth, if date of birth is known, we don't have to enter the age, because based on the date of birth and the present date, okay, today's date, if we combine these two together, a combination of these two will give us age. So in this case, what happened is that date of birth is a stored attribute. That means the value of the attribute is stored, But age is a derived attribute. Derived attribute means the value of the age is derived from the attribute date of birth. So in this case, there is a relationship between these two attributes, date of birth and age, because we derive the value of age, that is 24 in this case, from the date of birth, which we are entering it directly, or that is called a stored attributes. So that is how some attributes can be derived. Okay, or you suppose if I want to find out, I have in the beginning we said we have students. So if I want to find out number of students, then just by making the system, the database count the number of entities which is entered, students, number of students can be derived from this. Okay, by counting the number of uh, entities under the entity type, the students. Okay, then the value of the attribute, which we said is the on ultimately what we store, can be null. That means the value can be blank or it can be zero. Okay, so we may leave the value empty. So entity without an applicable value for an attribute. Now, if we go back here, for example, you have not, if you look at educational qualification, suppose we are saying that what is a postgraduate? Okay, let me put it here. If I said uh, in a particular form, when you fill up a particular form, educational qualification, they are saying postgraduate. Since you have not completed postgraduate, you leave this. What do you normally write? Not applicable, right? So not applicable because you don't have a postgraduate degree. So in this case, when you say not applicable, that means you are leaving that this particular attribute value as a null value. There is no value because it's not applicable. Now, for example, in the address, we mention something like apartment number. Sorry, apartment number. So suppose you are not living in an apartment, rather you are living in an independent house. Then this apartment uh, number, the value for this apartment number will be empty, not applicable. Then also the value for this attribute will be a null value. So for such situation, this is what we call a special value called a null is created. Now, null values can be used when the values of the attributes are not applicable, or it can be unknown, you don't know, or the value is missing. So suppose you are doing the data entry from some other sources, the value is unknown or the data is missing, then the value, that attribute value will be a null value. Now coming to the most, I mean, the last but not the least attribute, it is called complex attributes. So composite and multi-valued attributes can be nested. Okay, so we can represent arbitrary nesting. That means by grouping components of a composite attribute between parentheses. For example, we said address, and then we say phone number. Then we said phone number will have area code or country code, then the phone number, then we can have we can also have a street address. The street can have street number, then the street name, or the apartment number, and then you can have a city, the state, the postal index number. That way you can combine all of these things as an attribute. Then this becomes, that means we are having a, uh, I mean, rows and rows of or arrays of values. Then the attribute becomes a complex attributes. Okay. So this is achieved by using brackets and parentheses. Okay, this kind of representation is used in entity relationship model. Now let us come to the entity types. Now we understood what is entity relation and what is entity, what is attribute, and how these things, how entities can be related. Now, entity types. Entity types defines a collection of or a set of entities that have the same attributes. So here we give an example of student as an entity, okay, as the name of the entity. It is not only name of the entity, but it also represents a type, an entity type, because this is not just one entity, rather it is a collection of entity which have similar attributes like name, roll number, age. These are all similar attributes. So if you look at these entities, individual entities, Evangeline Wanyang, for example, is the name of the student, one of the student whose roll number is 1 LIS01 and whose age is 24. Then we have the next entity is Mausami Karmakar, whose roll number is LIS02 and who is 23 years old. And as we go on and on, ultimately we come to the 22nd entity, that is this entity's name, the student entity name is Dilme Sangma. Roll number is LIS22, age is 22. Then as we move on and on, ultimately we come to the 30th student or the 30th individual entity, that is Pinskem Suting, whose roll number is LIS30 and who is 23 years old. So if we look at this, entity types, okay, when we say entity types, defines a collection of entities that have the same attributes. Okay. Now, similarly, departments is name of the entity. Department is name of the entity, and it also defines the entity types. What type of entity types? An entity which has the attribute value, name, head, and the campus. So in this case, the first department is Library and Information Science. Head is Professor B. Lalu. Campus is Shillong. Then the second the second entity is management. Name of the department is management. The head of department is Professor K.C. Biswal. Campus is Tura. Similarly, the next one is biochemistry. Name of the department or name of the entity is biochemistry. Head of department is Professor A.K. Singh. Campus is Shillong. All right. So this is name of the entity, as well as it also represents an entity type. What type of entity? The entity type whose name is department, and it also which has attributes, the following attributes: name, head, campus. So an entity types defines a collection of entities that have the same attributes. So each entity type in a database is described by its name and attributes. Okay. Now, the collection of all the entity types in a database, okay, the collection of all entity types in a database in a database at a particular time is called an entity set. The collection of all entities of a particular entity types in the database at any point of time is called entity set. Now let me give you one example. Here we have an entity type, and then it has attribute name, attribute as name, roll number, and age. Okay. Now we have the attribute. The entities are Evangeline, Mausumi, Dilme, and Pinscamp. These are the uh, the entities that is represented under these entity types. Now, for example, Mausumi Karmakar has left the course, so we delete it. Now, yesterday her name was there, so in the yesterday's entity set includes Mausumi Karmakar. But today, since we have decided to leave the course, in today, Mausumi Karmakar's name is deleted. Therefore, the entity set has does not have Mausumi Karmakar in the list of entities, right? So that is why what we are saying is that at any point of time, this collection of entities can change. Individual entities may be modified, maybe the values may be modified, or for the value or the values may be deleted. Okay, at any point of time. So it keeps on changing. So if you look at any point of time, yesterday, today, tomorrow, that is called an entity set. What is there at present at this point of time, that is called at any given point of time, that is called an entity set. Similarly with the department as well. Now when we come to the ER diagram, how this is how entity relationship diagram is represented. The entity types is represented in ER diagram as a rectangular box. For example, in this case, I've given students. So students is represented in the rectangular box. And then the name of the, the attributes are represented in the in ovals, right? Attached to the entities. This name, roll number, and age are attributes of what entity? In this case, the entity students. These are attributes of the entity students. Therefore, they are in oval and attached with a straight line to the entity it represents. All right. So that is how in ER diagram entity and attribute is represented. Then it also has composite attributes. If, so for example, name is a composite attribute because name can be divided into first name, middle name, and last name. So it can be composite attribute, described as a composite attribute. Then the part of those composite attributes will be connected to the attribute it represents, because this first name, middle name, last name are part of an attribute called name. So it is attached to that. Okay. And then one thing, if the attribute is multi-valued attribute, all right, if it is multi-valued attribute, then that value will be represented by having double line. It will still be oval, but it will be double circle. Okay, that will be double circle. Now I have underlined this particular attribute, roll number. I have underlined it is because this can be used as a key attribute. So now I'm introducing one new attribute, that is a key attribute. Now a key attribute is used, as we said in the beginning, that entity relationship is about entities, attributes, and relationships. So to see what are how to in order to relate the entities, some of the attribute values, the value of the attribute values, which is likely to be unique for its individual entity, can be used as a key attributes. Okay, key attributes. Now, what in other words, what I mean to say here is that suppose we have a collection of students. Names can be the same. Two students can have the same name, the same surname. Two students can have the same age, which is most likely. But in order, even if those things are there, these two students are having the same name, the same surname, we can separate those students when we can identify those similar students by giving them a unique roll number. That means two students will not have the same roll number, so roll number becomes unique. So that means that every individual student, a student's name may be A, B, C, C, D, E. For example, C, D, E is 2, E, F, G. These are the students. But in the roll number, we give them 1, 2, 3, 4. Though these two students are similar, they can be singly identified or they can be uniquely identified by their roll numbers. Now, that way, in the database system, we'll be able to set relationships. Okay, it can be used. Now, in this case, roll number is the key attribute. So these can be used to relate with other entities, which we have introduced in the beginning. So these are key attributes. So it is important constraint on the entity types. Okay, key attributes are important. Oh, here it is. Okay, I'll come to that. Now, okay, an entity type describes, okay, now coming to the entity type again, it describes the schema or the intention for a set of entities. Okay, a set of entities that shares the same structure. So a collection of entities of a particular entity type are grouped into an entity set, which is also called the extension. Entity set is also called the extension of the entity type. Now, key attribute is an attribute of entity type whose values are distinct. Okay, that's what we said. Distinct for each individual entity in the collection is called a key attribute. So this is used for what? To identify its entity uniquely, right? I give you an example of a name of students, roll number. So somebody is ABC, the next one also is ABC, CDE. So these two has the same name. So we cannot differentiate it, but we have unique. If you have unique roll number 1, 2, 3, then this can be ABC with roll number 1, ABC with roll number 2. That is how we identify them uniquely. So key attributes of entity type is an important constraint, okay, on the entity of an entity type. Now, you can have a combination of attributes also, can also be used, okay, can also be used as key attributes. It can be done by forming a combination of attributes, means we can have a composite attributes, okay. When there is no key attributes, then we can combine them. We can combine some of the attributes together by forming a composite attribute. Then it can be made to become a key attribute which will uniquely identify its individual entity. So then we have the value sets. This is also one important aspect of ER diagram. Its simple attributes of an entity is associated with a value set or a domain of values. The set of values that may be assigned to that attribute for each individual entities. So this domain of values specifies the set of values that may be assigned to that attribute for each individual entity. So Say, for example, if we say that uh, sorry. Now, let us say we represent an entity called government employees. Okay, government employees have names. Government employees will have age, will have whatever designation, and so on. So now what happened is that, say the government rule says that a person can join a job, a government job, uh, at the age of 18 and should retire by the age of 60. That means this value, as per the rules specified, this value age, okay, this we have a domain value which is from 18 to 60. So you cannot have an age which is lesser than 18. The value cannot be greater than 60. So this is what we call a value set. Okay, from 18 to 60 it can be assigned. If you end up assigning uh, uh, outside this range or domain, then you will have an error value. That is called value set. So it can be also a set of you can have a domain. For example, we said name will be only character string. Okay, we can say the character strings. So that means in name you cannot say that somebody's name is ABC2. You cannot have 2 because we are insisting that it has to be character string. Okay, so you will be using ABC alphabetical characters. Maybe in this case, uh, okay, if we say this has to be alphabetics, then you will have the value set will be taken from the uh, data type alphabetics. Similarly, designation, for example, there are a designation, let us say scientists A, B, C, D, E, F, for example. This is a scientific institution and all designations are all scientists only. Then you can take it from this predefined value set only. So that is more or less about entity relationship. Uh, we will, in the upcoming classes, we will also try to see some other aspects of the entity relationship. So with this, we have come to the end of the class.